What we have here is an air core transfer of energy from a smaller 12-pound coil to a larger 75-pound coil underneath of both of 23 gauge wire, and it's a resonant circuit. Each inductive element has a capacity in series with it, and our power input should be shown about 25 volts, and we got a load on that secondary, and we got the appropriate amperages there, and our load is a ballasted neon. Sometimes when we film this, ballasted neon seems to do some bizarre effects, such as go on and off, which I think it might have just did. It's flickering. There's a ballasting problem with that kind of flickering, but we want to note here, I have to get the cat paw out of there. Poojies. Poogie. Come on, Poogie. Yeah, skit. We got a 0.11 amps, and we got 23.7 milliamps. Okay, what we're going to do then is we're going to disconnect that load. Okay, where are we at here? We can disconnect it right there. Now we can see the true ratio of delivery on that secondary. We could also see that, if we recognize what those quantities were when we started, we'll have to show that again. We're at 33 milliamps, 23 milliamps, 23.9. The primary changes were 0.11 to 0.08 amps. Okay, then we got an idea of efficiency there. And now what we're going to do is completely disconnect the secondary from the primary through this plug right here. Well, what happened? That might have just went off by itself. So we got 0.16 amps unloaded secondary and 0.08 amps loaded. Okay, the question here then for all these relativity fanatics, I got this plug here. Are these same ratios going to be observed when I take the plug powering the primary out, short it out, and then plug this into the power source instead? So that's what we're going to show in the next video, but hopefully we might get some opinions as to what should happen, and I think we'll call that quits for now.